Hello, everybody. What I'm going to do today is talk about the radial point plotting tin and contours lab. I want to give a quick little how-to as far as the radial point plotting. This video will not be too terribly long because I'm not going to plot every single point by hand, but I want to do a few of them just to kind of get you started. Some of the equipment that we're going to start off with, I have two triangles, a 45-degree triangle and a 30-60. I have a 360-degree protractor, and I have my engineer scale, and of course, a pencil. This particular lab, we're going to do at a 10 scale. So on your engineer scale, we'll find the 10 scale where this means 1 inch equals 10 feet. So where you see starting from 0, this 1 would be 10 feet, 20 feet, 30 feet. The next longest line in the middle would be 5 feet. Then the smaller lines, that's every 1 foot delineation there. With my protractor, I want to look at this real quick here. And again, this is broken up. So where I have the 10, 20, 30, the large lines, the numbers, how well you can see that there, those are 10 degrees. The longer line in the middle would be every 5 degrees. The next longest line is every 1 degree, and then every tiny degree or tiny line is half a degree or 30 minutes. Now I specify, okay, this is graduated to the nearest 30 minutes, and our scale is graduated to the nearest foot. Bear that in mind when you're looking at the angles and distances. We can actually, just with this equipment, measure to the nearest foot and to the nearest 30 minutes. So if you go any further than that or try to get a little more precise than that, you're just going to be estimating, which is okay. So I have my blank sheet of paper here, and I better mention, when I'm using my triangles, I'm left-handed. So if you try to mimic exactly the way I'm holding triangles and moving them around, it might be very awkward to you. Kind of find a way that works better for you to manipulate the triangles. So with this point plotting lab, I have two control points, point number 11 and point number 12, and I provide a bearing and distance between those. The bearing is really the most crucial part. The distance, not so much, because the bearing line is going to be our reference from where we measure every other angle from, all our horizontal angles. And with this too, I want my north arrow to be pointing straight up the page. So the sidelines of the paper, think of those as due north, due south. The top and bottom lines being due east and due west. I provide a bearing between points 11 and 12, north 85 degrees, 52 minutes, 19 seconds east. So I would like to draw that at an accurate orientation. I'm going to put my starting point on the regular Cincinnati State sheet here, right about this spot right here, which if you take a 10 scale, I'm kind of roughly doing about 32 feet to the right of the left border and roughly 81, 82 feet below that top border. So what I first need to do in order to draw that bearing is I need to establish a north-south line going through that point. The way I'm going to do that is using my triangles. Again, I said I want to use one side of my sheet here, the border, to be my north-south line. So I'm going to take my long triangle, line that up, hold down the bottom guide one, if you will, slide this over, and I'm going to just draw a nice, very faint line through that point. So this line is now parallel to my property line, or I'm sorry, the border. Another way you can do this, if you choose, using the 45 triangle, if you were to line it up with the top and turn this 90 degrees, or well, 45 degrees, you can slide that down and come up with that same parallel line. So now what I'm going to do is I'm going to take my protractor. I am going to put the center of my protractor at where I'm calling point 11. I'm going to line up 0 and 180 on my protractor, 0 being at the top, that 180 or 0 down at the bottom. So it's oriented north-south. So this bearing is north 85 degrees, 52 minutes. We know bearings are all referenced from the north-south line. So they start at north and go east or go west, or they start to south and go east or west. And bearings are never greater than 90 degrees. So I'm going to come over here 95 or 85 degrees, 52 minutes. Here's my 80, there's my 5. I'm going to go close to 86 minutes and put a little dot for my orientation. I will now start at point 11, line up my scale or my triangle along that orientation, and I'm just going to draw a semi-faint line through that. Now, I have a distance to point 12 from point 11. That's 195 feet. If you actually try to scale that, my scale only goes up to 120 feet. So just for the fun of it, if I were to say, okay, here's where 100 feet is, and then I would need to go another 95 feet, that's going to put me over here off the paper. Again, I'm not really concerned with where point 12 physically is. This is our reference line. So what I have is a topo where I set up a total station on point 11 and took a backside of point 12, which is represented by my orientation line here. From there, I'd start running around locating all these various points. The total station measures angles from a baseline, a reference line from my backsite, and sets 0 along that baseline. From there, that's where all the angles are turned to the right or turned clockwise. What I want to do with my protractor now, this is basically going to represent like the total station out in the field. I am going to set the center of my protractor at point 11. I'm going to set my 0 line along my reference line. And essentially, this is the orientation this protractor is going to stay for the entire portion of this lab. So if I look at my very first point, point 100, I'm looking at an angle of 235 degrees, 10 minutes. So I come around 180, 190, 200, 10, 20, 35, 10. I'll make a real faint tick mark there. I'm going to take my scale, and the distance, which is a horizontal distance, is 30.69 feet. So 30 and a half, 31, however you want to actually mark that. Because again, this is only graduated to the nearest foot. Anything in between is estimating. I'm going to estimate my 30.69 feet right there. I'm actually going to set a point there, put an actual dot here. Now, what I also want to do is I want to write down what I have for a code and an elevation. I have on here, on your sheet, the feature code and the full description. Give you a little example of what that means. The feature code is an abbreviation of what the actual feature is or what the description of the shot. For this one here, I called this EP1 space B. Over in the full description, I have an actual full description of what that abbreviation means. That's the edge of pavement begin line. What I would recommend doing is next to your point there is write down, I'm gonna go EP1 begin. I'm gonna write this kind of light as well. And the elevation, 935.64. Okay, that's it. That's my very first point. You do not need to draw any lines from here out. You just need to put your point there. I shot a handful of things. I'm going to go down to the next edge of pavement. I have an angle of 307 degrees, 42 minutes. So again, the protractor is my representation of my total station. So the center point, I'll write 11 right there just so we can see. The center where the instrument was set up is at point 11. I reference the orientation, my 0 line along that baseline. And now I'm going to measure to this other point, which is going to be point 110. 307 degrees, 3 minutes. So 300 and 5, 6, 7. I'm going to put a little tick mark there. I use my 10 scale, and this has a horizontal distance of 30.20 feet. So with 0 at point 11, the scale, think of this as representing the distance that the total station measured. It falls right about there. Again, I'm going to make a little dot. This was coded as EP1, and this has an elevation of 933.01. I'm also going to do a little check mark on my list as I go down it and fill these out, just so I know exactly where I'm at. Let's look at another one. I'm kind of just randomly picking some things here. What you have, shots that I took were edge of pavement, tops of bank, ditch lines, an invert. There was a pipe going underneath the driveway. So these edge of pavements are going to mark the main roadway, driveway coming up into this little park where I was at, and then there's also some asphalt walkways going around the park that I shot. There's some fence line. There's also some ground shots, which are just kind of random spot elevations to better model how the ground is laying out. Let's see, what else should I do? How about, let's do my fence line. What I'm going to do here, okay, my protractor is back. The center is at 11. 0 is marked at my reference line. Again, I'm just kind of randomly jumping around here to do a couple of these kind of quickly. My fence line begin is at an angle of 207 degrees, 42 minutes. So that's, let's see, 180, 190, 200, 5, 6, 7. Oh, excuse me. There's my orientation. We'll take my scale, and the distance to that point is, let's see, 22.57 feet. So 22.57, we'll just estimate right about there. put my dot. That's a FL1 begin. And that has an elevation of 935.61. I'm going to do this other one here. This might be about as far as I go with the point plotting. Center of the protractor at point 11. My 0 along the reference line. And this last one here that I want to do real quick is angle of 341 degrees. 270, 280, 300, 310, 341, 28. So about 341 and a half. There's my orientation. And the distance to that is 23 feet. So 0, line up. We said that's 23 feet. 20, 1, 2, 3. Make my little point. It's an FL1E at an elevation of 932.60. Okay, so I just plotted out 4 points really quickly here. Just wanted to kind of give you a quick how-to. What you are going to want to do once you get all your points plotted out is you're going to want to take all the codes that are similar and connect them for your actual line work. This is going to come into play when we do the 10. I will make another video of going through the 10. So we'll start EP1 begin and draw that line in between. I'm going to make it a bit darker. My fence line begin to my fence line end. Again, those are going to be a little darker. So what we have here is a total of 47 points to plot out. I just did a quick video here, again, just how to plot out these points. You recall when the beginning of the semester we did the plat drafting, we had to have our north-south line and we oriented our protractor to north-south, drew our bearing, then went down to that point, oriented north-south, draw the next bearing. The only bearing you're going to draw is from 11 to 12. That's the only bearing. Then everything is going to be from point 11, the center of your protractor goes to point 11. 0 degrees is going to be on that reference line. All of your angles are going to be measured clockwise or angles to the right. And that's how you start plotting your points. I will come back with another video on actually interpolating and building the 10. Okay, so what I'm showing you here is we have all our points plotted out. Yes, I cheated. This is in CAD. But what I have here are all the points plotted out. I have all of my like points connected. And this is what it should basically look like. Here's my baseline from 11 to 12. And then the edge of pavement, these are the 2 edge of pavement shots that I first plotted out. And then the first fence lines that I plotted out. Once you get all 47 points plotted out, again, connect all the like points so your edge of pavements all connect. You have some center line connecting, edge of pavements kind of coming around. There's an asphalt walk. And then this is going to show the asphalt walk and the driveway going in. And you have another fence over here. There's also this ditch line, which you're going to want to connect. There are 2 invert shots I just want you to be aware of here. as far as the tin is concerned, kind of ignore those for now. The shots called invert are to show the beginning and ends of this culvert pipe that was crossing this driveway. As far as the tin is concerned, I would not worry about them right now. So once you get all the points plotted and all your lines connected, this is what this should start looking out. Now, when we create a tin, what we're going to do is connect the dots, connect these, connect all these lines actually. These edge of pavements, the fence lines, your top of bank, your ditch lines, these are all going to be part of your tin, your triangles. The tin being a triangulated irregular network. You do not have, these will always be edges of a triangle. So what I mean there by that is you are going to take your triangles and start connecting the dots. So I'll grab my triangle here. And what I mean, for example, like I'm going to take this edge of pavement and go to this center line and draw a line. I'm going to go from this center line to this edge of pavement, this center line to this edge of pavement, from this edge of pavement over here to the center line, connect these, connect these. So you see here, this is one triangle like so, another triangle, another triangle, and another triangle. You're going to do that for the whole entire thing. Now I mentioned that these, the edge of pavements and everything, these are feature lines. In the tin world, we would call those break lines. Your tin will, when you're drawing your triangles, they never cross these. And what I mean by that is, say, for example, like this ground shot in this fence line shot, you would not ever want to draw and connect those two together because that would cross two break lines. What you would want to do is take your ground shot over to this edge of pavement, this ground shot over to this edge of pavement to create a triangle like so. Connect these ground shots, connect these ground shot to this edge of pavement, and we'll connect this edge of pavement over to this ground shot. So here's triangle, triangle, triangle. No triangle should ever cross one of these feature lines. So let's go ahead and get to drawing those up.